Do you live in California, Texas, Arizona, or anywhere across the southern United States? Do you live in Australia, Indonesia, the Philippines, or anywhere in southern Africa? Do you live in Peru, Ecuador, or along the Pacific coast of South America? If the answer is yes to any of those, then what just happened this week deserves your full, undivided attention. Because as of June 12th, 2026, NOAA's Climate Prediction Center has officially issued an El Niño Advisory, confirming that El Niño conditions have now developed in the tropical Pacific Ocean. And they are not just expecting it to hold steady. They are expecting it to intensify, to strengthen into what they are already calling a potentially very strong event by fall. And buried inside that advisory is a number that should stop you cold. A 63% chance that sea surface temperatures in the monitored region of the Pacific will exceed 2 full degrees Celsius above normal by this coming winter. 2 degrees above normal doesn't sound like much, but to climate scientists, that number means something very specific. That is the threshold at which NOAA officially classifies an El Niño as very strong. We are not talking about a mild disruption to rainfall patterns. We are not talking about a slightly warmer winter. We are talking about a potential reorganization of weather across the entire planet, affecting billions of people, altering agricultural seasons, reshaping hurricane tracks, drenching some cities while turning others into tinderboxes. The question is not whether El Niño is here. It is here. The question that scientists are wrestling with right now, in real time, is just how powerful it is going to become. But here's the problem. The last time the Pacific looked this energized this early in the season, the world wasn't prepared for what followed. And the data coming out of the ocean floor right now is telling a story that not enough people are paying attention to. The Walker Circulation, a massive east-to-west flow of air that is driven by the temperature and pressure difference between the warm western Pacific and the cooler eastern Pacific, has already begun to break down. When that circulation collapses and warmer water shifts east toward South America, the official declaration of El Niño follows. That declaration happened this week, but the process has been building for months. Sea surface temperature anomalies in the Niño 3. 4 region, the key monitoring zone stretching across the central equatorial Pacific between 5 degrees north and 5 degrees south latitude, have been climbing steadily since early spring. By mid-May, weekly values had surged well above the threshold. The last 3 weekly readings before the advisory was issued showed the Niño 3. 4 index firmly at +0. 9 degrees Celsius and accelerating. That is not a borderline signal. That is a clear and forceful crossing of the line. And now it gets worse. The International Research Institute for Climate and Society, working out of Columbia University, has issued its own probability assessment. Their forecast shows a 98% probability of El Niño conditions persisting through May to July of 2026, and then maintaining that remarkably high confidence level all the way through February of 2027. 98%. That is not a forecast with significant uncertainty baked in. That is near certainty. El Niño is here, it is strengthening, and the models are aligned in a way that scientists almost never see across the board. The World Meteorological Organization, the same international body that sets the global scientific standard for climate monitoring, released its own update just days ago. Their assessment puts the likelihood of El Niño conditions persisting through June, July, and August of this year at 80%, and the probability that those conditions continue at least through November is near or above 90%. Wilfran Mufuma Okia, the chief of climate prediction at the WMO, put it plainly. He said that after a period of neutral conditions at the start of the year, climate models are now strongly aligned, and there is high confidence in the onset of El Niño, followed by further intensification in the months ahead. This next part matters, because understanding what is physically happening beneath the surface of the Pacific Ocean right now helps explain why forecasters are so concerned. The Pacific Ocean is not just warm on the surface. The anomaly extends deep. The top 300 meters of ocean water, a layer that climate scientists watch closely because it holds thermal energy far longer than the surface alone, has been absorbing heat for months. Surface anomalies come and go with the wind. Deep layer anomalies last. They are a forecasting signal that the energy driving this event is not shallow. It has roots, and those roots go down through hundreds of feet of water that will continue releasing heat into the atmosphere for months to come regardless of what happens on the surface. There was also an unusual atmospheric trigger earlier this spring that may have helped accelerate the timing. In April, a rare set of triple cyclones formed in the western Pacific. Scientists tracking ENSO development noted that these storms pushed warm water eastward across the Pacific toward the exact region where El Niño conditions are monitored. It was an extraordinary confluence, a kind of atmospheric assist that appears to have nudged the transition faster than some models expected. Most people are missing this. There's a tendency to hear El Niño, and think of it in general terms, as a weather pattern that makes some places wetter and some places drier. That framing does not do justice to what is actually at stake. El Nino does not politely redistribute rainfall from one region to another. At its strongest, it rewires the jet stream. It displaces the atmospheric rivers that feed winter storms into California. It dries out the monsoon rains that hundreds of millions of farmers across South and Southeast Asia depend on. It pushes drought into parts of Australia so severe that the land becomes fuel for fires. It floods coastal Peru with rainfall so extreme that communities that normally see 6 inches a year have received 11 feet in a single season. It is not a weather event. It is a global climate reorganization that plays out over 12 to 18 months and touches every region on Earth in some way. And tonight changes the timeline, because NOAA's advisory was not a distant warning about something that might happen next year. It is a confirmation that the conditions are already present, already measured, already building beneath the surface right now in June. Here is why this is serious for the southern United States. El Niño winters historically bring a pronounced shift towards stormier conditions across the southern tier of the country. The southern jet stream strengthens and dips further south than usual, dragging moisture-laden Pacific air deep into the continent. That means cities like Los Angeles, Phoenix, Tucson, Albuquerque, San Antonio, Houston, New Orleans, Jackson, and Birmingham could see significantly above average rainfall during the fall and winter months ahead. For communities that have spent years in drought conditions, that sounds like relief. And in some ways it is, but it comes with a price. The central coast of California is already being discussed in terms that are difficult to absorb. Meteorologists tracking the developing El Niño are raising the prospect of 40 to 50 inches of rain in areas near Santa Barbara and San Luis Obispo that typically receive 14 to 24 inches in a normal year. That is not extra rain. That is a different climate entirely. And for communities near burn scars from recent wildfires in the Santa Lucia Mountains, the Los Padres National Forest, and the Santa Ynez Range, rainfall of that magnitude does not soak into the ground. It rips through it. It carries the loose debris and ash-saturated soil downslope in mud flows that can bury roads, fill creek beds in minutes, and reach neighborhoods in the dark of night while families are asleep. The Salinas River, San Luis Obispo Creek, and coastal areas that already manage high tide flooding are all in the planning conversations happening right now. But that is not the real story for California alone. High tide flooding could become a compounding threat up and down the west coast. NOAA's own advisory specifically flagged it. Warmer sea surface temperatures push ocean levels slightly higher. El Niño storm systems generate larger waves and higher surf. And when those atmospheric rivers come ashore during high tide windows, the combined effect, what forecasters are calling a potential double whammy, can overtop seawalls, flood coastal roads, and send water into neighborhoods that have never seen salt water before. Now the focus shifts to what is happening across the ocean. Because El Niño's reach is not regional, it is planetary. And some of the most severe impacts are forming right now in places that are already vulnerable. Australia is facing what climate analysts are calling a period of extraordinary risk. For Australia, El Niño reliably brings hotter and drier conditions. The last strong El Niño in 2019 and 2020 contributed to the conditions that produced the Black Summer bushfires, which burned over 46 million acres, killed or displaced an estimated 3 billion animals, destroyed more than 3,000 homes, and blanketed Sydney and Melbourne with smoke so thick that air quality monitors couldn't register it accurately. That was during an event that peaked around the moderate to strong threshold. The current forecast, with a 63% chance of reaching very strong classification, suggests what lies ahead for Australia could be of a different order of magnitude. Vegetation will dry earlier in the season, fire weather days will come sooner and burn hotter, and the windows of time when firefighters can conduct controlled burns to reduce fuel loads will be shorter and less predictable. In Indonesia and the Philippines, the signal is equally severe. El Niño disrupts the western Pacific monsoon system that these nations depend on. Rainfall that normally arrives in consistent seasonal patterns instead comes late, or fails to come at all. For farmers growing rice across Java and the Visayas, missed monsoon rains are not an inconvenience. They are a catastrophe. Rice paddies go dry, harvests fail. In rural areas already stretched by economic pressures, food prices spike, and the families who can least afford it bear the full weight of a weather pattern that originated thousands of miles away in the central Pacific Ocean. In India, the monsoon relationship with El Niño is one of the most studied and most feared dynamics in global agriculture. Strong El Niño events historically correlate with below-average monsoon rainfall across central and northern India. In a country where agriculture feeds hundreds of millions of people and where groundwater tables in many regions are already at critically low levels, a weakened monsoon season does not just affect farmers. It affects drinking water supplies. It affects the power grid in states that depend on hydroelectric generation. It affects the price of everything grown in soil. This is where it becomes dangerous. Because when you overlay all of these regional impacts onto a single global map, you begin to understand what a very strong El Niño means, not just for weather, but for stability. The UN Office for Disaster Risk Reduction has projected that this developing event will likely lead to asymmetric impacts, with drought conditions reducing corn, rice, and wheat production across Asia and Australia, while enhanced precipitation boosts soybean yields in parts of the Americas. Crop losses and crop gains happening simultaneously in different regions does not balance out. It creates price volatility in global commodity markets that hits food insecure populations hardest. And one more thing you need to know. Climate scientists studying the 1997 to 1998 El Nino, the event that most climate agencies still use as the benchmark for what a very strong episode looks like, have recently published findings that reframe how we understand the human cost of these events. A study published in Nature Climate Change earlier this year estimated that the 1982 to 1983 El Nino resulted in a monetary equivalent loss of $6 trillion in reduced life expectancy across Pacific Rim nations alone. The 1997 to 1998 event produced an equivalent loss of $7 trillion. These are not damage estimates from destroyed infrastructure. These are estimates of years of human life lost, converted into an economic equivalent, because mortality rates increased in the aftermath of droughts, floods, disease outbreaks, and food shortages that all traced back to a shift in Pacific Ocean temperatures. The 1997 to 1998 El Nino was classified as very strong. It caused an estimated $32 to $96 billion in direct economic damage globally. It warmed average global air temperatures by 5 degrees Celsius above the baseline compared to the typical 25-degree increase associated with ordinary El Nino events. It temporarily killed an estimated 16% of the world's coral reef systems. It pushed already warm ocean temperatures into ranges that bleached vast stretches of the Great Barrier Reef. In Peru, it deposited 11 feet of rainfall in areas where 6 inches was considered a normal year. The trade winds that normally held the warm water in the western Pacific didn't just weaken during that event. In parts of the system, they reversed entirely. The Pacific is sending similar signals right now in 2026, but here's the problem that forecasters face when communicating this to the public. El Nino takes months to reach its peak. The impacts of what is forming right now in June will not be fully felt until this coming winter, and in some cases not until late in 2027. There's a lag built into the system. The ocean heats slowly. The atmosphere responds slowly, and by the time the flooding starts, or the drought deepens, or the wildfire season arrives, the connection back to this week's NOAA advisory can feel invisible to the people living through it. That lag is not an excuse to wait. It is precisely the reason to act now. What happened next changed everything about the forecasting picture. In the weeks before NOAA's official advisory, the European Center for Medium-Range Weather Forecasts, one of the most respected modeling agencies in the world, issued its own assessment indicating high likelihood of what it classified as a supercharged version of the climate pattern emerging this summer or fall. The ECMWF and NOAA are not the same organization and do not always agree. When they align, that convergence carries significant weight in the scientific community. They are aligned now. For the United States Gulf Coast, the implications of El Nino's development carry a specific silver lining that is worth acknowledging, even in a story this serious. El Nino suppresses Atlantic hurricane activity. Stronger upper-level wind shear over the Caribbean and the Gulf of Mexico tears apart developing tropical systems before they can organize. NOAA itself referenced this dynamic in its advisory, noting that the current development is consistent with a below-normal Atlantic hurricane season for 2026. For communities from Brownsville to Miami, from New Orleans to the Outer Banks, that is a meaningful signal, but it is not a guarantee. And it does not erase the flood risk that comes from the atmospheric rivers and winter storm activity that El Nino typically enhances over the South. This is where it becomes dangerous for a different reason. The public attention that a suppressed Atlantic hurricane season generates can actually work against preparedness for the winter flooding threat that replaces it. Families in Houston, San Antonio, and Corpus Christi, who spend the summer quietly relieved that the Gulf stayed quiet, may not be fully prepared when the rains of December and January arrive, in volumes that turn creek beds into rivers and rivers into spreading lakes. The flooding risk is not less under El Nino. It is different. It arrives later, it stays longer, and it often comes without the dramatic warning windows that a named storm provides. Most people are missing this. The discussion around El Nino in public conversation tends to focus on what it does to weather in a single season. But the science increasingly shows that the effects are not contained to the 12 months of the event itself. Drought conditions set in motion during a strong El Nino can persist into the La Nina that typically follows. Forests that desiccate during El Nino often burn during the following season. Agricultural shortfalls from one crop year ripple forward into food pricing instability the next year. The World Resources Institute flagged specifically that record-breaking fire activity in the Amazon is most likely not this year, but in the second half of 2027, when the reduced wet season rainfall from this El Nino leaves the following dry season even more arid and fire-prone. The Amazon matters to this story in a way that goes far beyond the region itself. The Amazon rainforest processes a staggering volume of water vapor, cycling moisture from the soil back into the atmosphere in a pattern that scientists describe as a flying river. That moisture travels eastward, feeding rainfall across Brazil and into Uruguay and Argentina. When El Niño drives drought conditions into the Amazon basin, that atmospheric moisture cycle weakens. Rainfall downstream decreases, the forests, already under pressure from decades of deforestation, become more flammable. And fires in the Amazon release carbon at a scale that contributes measurably to global atmospheric concentrations, compounding the baseline warming that makes strong El Niño events even more intense than they would have been in a cooler world. And now it gets worse. Climate scientists have noted for years that the frequency and severity of El Niño events is trending upward as the background temperature of the planet increases. A warmer ocean has more thermal energy available to fuel the anomalies that define a strong El Niño. The 2 degrees Celsius threshold that NOAA identifies as very strong is not a fixed scientific constant. It is a historical yardstick built from the record of events that happened in a cooler world. Some researchers argue that in a world where baseline ocean temperatures are already elevated by decades of anthropogenic warming, a +2 event in 2026 could carry more atmospheric energy and produce more extreme regional impacts than a +2 event would have produced in 1997. What happened next changed the way scientists described what was coming. Researchers began borrowing terminology from hurricane meteorology. Instead of just strong or very strong, the phrase Super El Niño began appearing in peer-reviewed language, in agency communications, and in headlines. Live Science, using data from NOAA's own climate models, described the current forecast as pointing toward potentially the biggest El Niño event since the 1870s, if the very strong threshold is exceeded during peak winter conditions. The 1870s reference is not a casual comparison. During the late 1870s, a Super El Niño event contributed to global weather disruptions, so extreme that historical demographers estimate it may have played a role in the deaths of as many as 50 million people across Asia, Africa, and South America through drought-induced famine, crop failure, and the collapse of water systems. That event happened in a world of roughly 1.5 billion people. The planet today holds more than 8 billion, many of them in exactly the regions that a very strong El Niño hits hardest. The agricultural systems feeding those populations operate with narrow margins. The water infrastructure serving them was built for the climate that existed before these anomalies began trending larger. This next part matters. For viewers in Peru and Ecuador, the signal is direct and immediate. El Niño is named literally for what it does to the coast of South America. The warm water that shifts east under this phenomenon arrives on the coast of Peru and Ecuador as a surge of heat that disrupts the cold, nutrient-rich upwelling that normally sustains the massive anchovy fisheries off those coasts. Fishing communities that have fed themselves and their nations for generations watch their catch collapse. In 1997 and 1998, the disruption to Peru's fishing sector alone contributed to economic damage measured in hundreds of millions of dollars. This year, with a very strong event potentially developing, those communities are watching the water temperature data with the same urgency that a farmer watches a drought gauge. For families in southern Africa, particularly in Zimbabwe, Zambia, Mozambique, and Stomao and South Africa's interior farming regions, the pattern is equally severe. El Niño historically reduces the summer rainfall that feeds the maize crop across southern Africa. Zimbabwe has already experienced the early consequences of a drought cycle that began during the transition away from La Niña, and those conditions are expected to intensify rather than ease as El Niño fully establishes itself through fall and winter. In a country where maize is not just a crop, but the caloric foundation of the national diet, a failed season does not produce economic statistics. It produces children at feeding centers. Here is why this is serious right now, at this moment in June of 2026. The timeline for preparation is not open-ended. El Niño impacts that will be felt in December, January, and February of this coming winter are set in motion by conditions that are already present in the ocean today. Water managers in California who need to pre-position flood control infrastructure do not have until November to decide. Farmers in Australia who need to select drought-resistant crop varieties for their coming planting season need that information now, not after the heat has already arrived. Emergency managers in Indonesia planning for potential food shortfalls across millions of people need supply chain adjustments that require months to execute. The season is already in motion. The ocean is already signaling what is coming. The window for organized preparation is open right now, and it will not remain open indefinitely. But that is not the real story. The real story is the gap between what the science is saying and what is making its way into the public consciousness. NOAA issued its El Niño Advisory on June 12, 2026. The data is clear, the models are aligned, the international scientific community is in near total agreement, and the probability figures attached to this event are some of the highest ever recorded at this stage of an El Niño development cycle. 98% probability from the International Research Institute, 80 to 90% from the World Meteorological Organization, 63% chance of reaching very strong classification from NOAA directly. And yet, most people have not been told what any of this means for their life, their home, their water supply, their food costs, or their safety. The advisory went out. The data is public. But the translation of that data into something that a family in Phoenix or a farmer in Tamil Nadu or a rancher in Western Queensland can actually use, that translation is still catching up. For viewers along the California coast right now, the time to think about storm drains, flood-prone streets, and backup plans for wildfire burn zones is not in November. It is today. For viewers in Australia's Murray-Darling Basin, where the river system that irrigates the continent's most productive agricultural land depends on snowpack and rainfall that El Niño characteristically suppresses, the coming months represent a planning window that cannot be recovered once it closes. For viewers in the Philippines, who rely on the spring rice harvest, understanding that the monsoon timing may shift this year is knowledge that changes how you plant, how much you store, and how early you start watching the reservoirs. What happened next changed what officials are saying publicly. Ken Graham, the director of NOAA's National Weather Service, put his own stamp on the advisory with words that carry their own kind of urgency when you understand the context. He said, and this is the framing that matters, every El Niño is not the same. Each one is unique with its own imprint on our weather. That statement is more important than it might appear. It is not a hedge. It is a warning against complacency. It is a reminder that the people who remember the 2015 to 2016 El Niño, which was also classified as very strong and which brought heavy rains to California while producing dramatic drought across Southeast Asia, should not assume this event will follow the same script. The background conditions of the ocean and atmosphere are different now than they were a decade ago. The baseline is warmer. The anomalies build on a higher foundation. The impacts, when they arrive, may arrive in forms and intensities that no previous El Niño has produced in quite the same combination. The atmosphere over the equatorial Pacific right now is not stable. The trade winds are weakening. The warm water that spent years concentrated in the western Pacific is moving east. The Walker circulation that normally keeps tropical thunderstorm activity anchored over Indonesia and Papua New Guinea is shifting. The center of gravity of the tropical atmosphere, the engine that drives global weather from the tropics outward, is relocating. And every time it relocates, the downstream effects ripple across jet streams, monsoons, temperature gradients, and rainfall patterns in ways that follow the physics of the atmosphere with relentless consistency. Families in Texas who experienced the brutal flooding events of recent years know what it looks like when rain comes too fast for the soil to absorb. Families in Arizona who have watched the Salt River and the Gila River run in ways they hadn't run in generations understand what happens when atmospheric rivers lock onto the southwest and refuse to move. Families in Georgia and Alabama, who watched flooding events reshape entire neighborhoods, know that what starts as a weather story becomes very quickly a human story, told in terms of lost cars, damaged foundations, missed work, and children pulled out of school. This system is not waiting for winter to begin its work. The ocean has already changed. The atmosphere is already responding. The forecasting agencies of the world's most technologically advanced nations are already aligned in a way that removes almost all meaningful doubt about the direction this is heading. The 63% chance of a very strong event is not the floor, it is the current estimate. It is built from the same ocean that was at +0, 9 degrees Celsius in mid-May, and was already accelerating by the time the June advisory was issued. If that rate of warming continues through July and into August, those probability numbers will be revised. And based on historical precedent, they are more likely to be revised upward than downward. The next 12 hours will not decide this. The next 12 weeks will. Every degree of additional warming in the Nino, 3. 4 region between now and September is another degree that will release its energy into the global atmosphere between October and March. Every additional week that the Walker circulation remains weakened is another week of thermal energy accumulating in the eastern Pacific that will eventually drive the atmospheric anomalies felt from Los Angeles to Lagos, from Sydney to Santiago. The Pacific Ocean is changing right now, tonight, as you watch this. The signal has been confirmed. The advisory has been issued. The models are aligned in a way that scientists rarely see at this stage of any developing event. And across 6 continents, in cities, and on farms, and in fishing villages, and in water management offices, and in emergency preparedness centers, the people whose job it is to watch for exactly this signal are watching it now and asking themselves how strong this is going to get. We will know more soon. The next ENSO diagnostic discussion from NOAA's Climate Prediction Center is scheduled for release in the weeks ahead. And it will incorporate updated sea surface temperature data, updated atmospheric observations, and updated model runs from every major forecasting center in the world. What it tells us will sharpen the picture, but the picture is already clear enough to act on. El Niño's here. It is strengthening. And the window to prepare is open right now.